The year is 1989, and after 12 long years in space, the Voyager 2 space probe is now passing Neptune, the farthest planet in our solar system. But for those of us back on Earth, it's 1977, and the Voyager 2 space probe is about to enter the orbit of Jupiter, the largest planet in our solar system. The year is 2006, and Voyager 2 has been in deep space for almost 30 years. Voyager 2 will pass Pluto, the dwarf planet at the edge of our solar system. The year is 2012, and after nearly 40 years in space, Voyager 2 is now in interstellar space and officially in the territory of the stars. It has been a wild ride for this little space probe, and it's managed to last this long thanks to some seriously cool physics. Now, Voyager was designed to survive for only 2 years, so how is it still alive after 40+ years? Why is it still sending back images of the cosmos? How did it escape our solar system, and why does it keep going? We're going to answer all of these questions and more. The very first thing that we need to talk about is the reason that Voyager 2 was launched into space in the first place. The Voyager program was the culmination of decades of engineering and scientific research. The goal was to explore the outer planets of our solar system: Jupiter, Saturn, Uranus, and Neptune. And maybe along the way they'd find some alien life too. There were 2 space probes built, Voyager 1 and Voyager 2. They looked identical and had identical instruments, with the exception that Voyager 2 had a slightly different set of cameras. The goal was for both Voyagers to fly by Jupiter and Saturn, but only Voyager 1 would continue on to explore interstellar space. When Voyager 2 was launched into space, it was traveling at a blistering 10 miles per second. At that speed, it would take the space probe around 250 days to reach Jupiter. But luckily, engineers had planned for a more efficient way to get Voyager to Jupiter by utilizing something called a gravity assist. A gravity assist is basically when a spacecraft uses the gravity of a planet to accelerate itself towards its next destination. And it's pretty brilliant because it saves on fuel costs. Basically, Voyager is able to steal some of the planet's momentum and kinetic energy, thus increasing its own speed. The next thing that we need to talk about is Voyager's trajectory. Basically, Voyager was launched in such a way that it would be able to slingshot itself around Jupiter and come out on the other side, traveling at a faster speed. And that's exactly what happened. On December 9, 1979, Voyager 2 flew by Jupiter and accelerated by a whopping 25 miles per second. That's roughly the same speed as a car traveling on a highway. The gravity assist around Jupiter allowed Voyager to reach the second planet in our solar system, Saturn. On November 25, 1980, Voyager 2 arrived at Saturn and spent a whole year orbiting the planet before beginning its journey again. The gravity assist from Saturn propelled Voyager 2 to the third planet in our solar system, Uranus, where it arrived on January 24, 1986. After spending another year orbiting Uranus, it was time for Voyager 2 to head to its final destination, Neptune. On August 25, 1989, Voyager 2 reached Neptune and became the first spacecraft to ever reach the planet. From here, Voyager 2 would begin its journey into interstellar space. Now that we've got the basics down, let's talk about how Voyager 2 escaped our solar system. To understand how Voyager 2 managed to escape our solar system, we need to first understand how gravity works. As we all know, every object in the universe attracts every other object with a force called gravity. The strength of this force depends on the mass of the objects and the distance between them. The closer the objects are to each other, the stronger the force of gravity between them. As an example, if you were to place 2 bowling balls near each other, they would attract each other with a certain amount of force. But if you were to double the mass of one of the bowling balls, the force of gravity between them would increase. Now imagine that you were to move one of the bowling balls further away from the other. As the distance between them increased, the force of gravity between them would decrease. So the further away they are from each other, the weaker the force of gravity between them. So how does this relate to Voyager 2 and our solar system? Well, At the center of our solar system lies the Sun, a massive star that exerts a strong gravitational pull on everything around it. All of the planets in our solar system are constantly falling around the Sun because they are not traveling fast enough to escape the Sun's gravity. Voyager 2, however, was launched with enough speed to escape the Sun's grasp. To understand how Voyager 2 managed to escape, let's imagine that the Sun is one bowling ball and Voyager 2 is the other. As Voyager 2 traveled around our solar system, it was constantly being pulled in by the Sun's gravity. But because it was traveling so fast, it never slowed down enough to be captured by the Sun. Eventually, Voyager 2 traveled far enough away from the Sun that the gravitational pull of the Sun became weaker than the gravitational pull of the planets. At this point, Voyager 2 was no longer in our solar system. Let's step back and consider Voyager 2's launch in 1977. Back then, computers weren't as powerful as they are today, and so the engineers had to do a lot of complex calculations by hand. They knew that in order for Voyager 2 to escape the Sun's gravity, it needed to reach a speed of at least 10.9 kilometers per second. That's equivalent to 38 kilometers per hour. Luckily, thanks to the gravity assists around Jupiter, Saturn, and Neptune, Voyager 2 was able to reach that speed. In fact, it was able to reach a speed of 13.5 kilometers per second, which is equivalent to 48.6 kilometers per hour. Once Voyager 2 left our solar system, it entered what is known as interstellar space. This is the region between the Sun and the next star over. And it's here where things get really interesting. As Voyager 2 traveled through interstellar space, it was no longer affected by the gravity of the Sun or any of the planets in our solar system. Instead, it was now being affected by the gravity of other stars. This meant that Voyager 2 was no longer in free fall around the Sun, and it was now on a trajectory that would take it far beyond our solar system. Currently, Voyager 2 is traveling at a speed of 13.4 kilometers per second, which is equivalent to 48.2 kilometers per hour. At this speed, it will take Voyager 2 approximately 40,000 years to reach the next star over, which is Alpha Centauri. It's hard to say exactly what will happen to Voyager 2 once it reaches Alpha Centauri. It's possible that it will be captured by the star's gravity and become a new planet. Or it could just pass by and continue on its journey. Either way, Voyager 2 will have successfully escaped our solar system. One of the things that makes Voyager 2's journey so impressive is that it was only designed to last 2 years. But thanks to some innovative engineering and some good old-fashioned luck, it's been able to last much longer than expected. One of the reasons that Voyager 2 has been able to last so long is that it's been able to take advantage of the gravity assists of other planets. This has allowed it to stay on course and keep traveling without having to use its own propulsion systems. Additionally, Voyager 2 has been able to take advantage of the fact that it does not need to worry about atmospheric drag. Since it's always traveling in the vacuum of space, this means that it doesn't need to expend any energy to stay on course. Finally, Voyager 2 has been able to take advantage of the fact that it does not need to worry about fuel costs. Since it was launched in 1977, fuel prices have skyrocketed. But because Voyager 2 was launched before the energy crisis, it was able to benefit from much cheaper fuel costs. All of these factors have allowed Voyager 2 to last much longer than expected, and it will likely continue to travel for many years to come. If you want to learn more about Voyager 2, check out the links below. Thanks for watching.